moved up with it, and so I need to put a $sign on the 2 so that the pKa always stays in that cell. Same here. Okay, now let's try this again. And it worked. So once you type it in once, you're done, right? All you gotta do is just copy it a bunch more times. So now we see here, if we had an initial case where we had 90% base and 10% acid, the ratio would be 9 and the pH would be almost 5, 4.95. When we add 0.01 moles of OH minus, the new pH becomes 5, actually 5.00, and if a delta of 0.05. Okay? So we can kind of just keep this symmetric, and let's see if I had an initial of 10% base and 90% acid, and I'm going to add base. We can see here how things change. Okay, does that make sense? So we've done it once, and the question asks for, let's just pick 20 different values between 2.5 and 5.5. So let's start at the top. I already know what the answer is, but let's just make a guess and say we have 0.97 percent base. That would give us 0.03, and then that would be a pH of 5.5. So that can be our top. Okay, and then let's see. This is going to be symmetric. So at the other end, we can put 0.03. And that would be 2.5. And now we just kind of need to fill in between these. So we're going to actually need a little bit closer at the ends because it's going to be steepest there. So let's try about every 0.01 for a while. And then 0.1. Okay, let's see. I'll just move this down a little bit. We'll keep it at every 0.1, 0.4, 0.3, 0.2, 0.1, 0.09. Oh, I see what I did here. I'll stretch it out a little bit. That's enough. There we go. Okay, so again, trying to teach you a little bit about the power of Excel. We've picked one column here, so we have 20. Also, you can see it anytime you highlight something down the bottom, it gives you the average and the count. So here's 20 numbers, and once we did the work once, now I can drag it up, drag it down, whichever way I want, and boom, there it is, all of it. Okay, now I want to make it's a bunch of numbers. It's really hard to make sense of. It's a lot easier to make sense of this if we plot it. So I want to make a plot of change in pH as a function of the initial pH. So I'm going to take these two columns. Let's see. working. There we go. Command. And I'm going to insert scatter plot. And there it is. Let's clean this up a little bit. I'm going to double click on it. And let's see, I want to double click on my x-axis. Here's my axis options. And it only goes from 2.5 to 5.5. So let's just go like 2.4 to 5.6. And that looks pretty good. And we're going from 0 to 0.2 on the y-axis. And if you look at figure 9.2, it looks a lot like this. Now remember, our pH or our pKa was at a different range or a different spot, but we basically just recreated the top half of this plot. So that's pretty cool. I want to add, I'm going to move this whole thing down 1. And all the formulas and everything should move with it. So everything is still good. And I'm going to make a note here that this is merge and center. This is adding base. So we've just completed part A. Now I want to repeat part A, but with the addition of 0.01 moles of HCl to each buffer solution. Okay. So I'm just going to do it right off to the side here. And let's see. A lot of the work is already done, but I'm going to kind of, just to make sure that I understand what I'm doing, do it again. So let's start. Now that we know where to start, let's try it. So we have 0.97 and a base. This is going to be equal to 1 minus that. And this is equal to base divided by acid. You know what? I'm not going to do this part. This is going to be exactly the same as these 3 columns right here. So I'm just going to, even this one's going to be exactly the same. So I'm just going to reference these same columns. All we want to do now, all we need is a new ratio, new pH, and delta pH. And this is going to be adding acid. Right, so now if we add 0.01 moles of HA, so if we add 0.01 moles of HA, H plus, that's going to react with the A minus and make HA. So the A minus will go down. It's going to be A minus less the amount that we added, and HA will go up by the amount that we added. And I want to make sure I go back in here and put dollar signs. Okay, so the ratio went from 49 to 24. No, I'm sorry, 32 to 24. New pH is equal to pKa $sign plus log 10 of the new ratio, and the delta pH is equal to the new pH minus initial pH. And notice that it's a negative number because the pH went down because we're adding acid. Okay? But also notice that this negative 0.129 is equal in magnitude to the positive 0.129 we had here. So we see how these are kind of reverse situations, right? When we had 3% base and we added acid, it changed up 0.13. Now if we have, sorry, I said that wrong. 3% base, we add more base, it goes up 0.13. Now we have 3% acid, we add more acid, it goes down 0.13. All right, now if I drag this down, I can fill in the rest of the table. You should see kind of a mirror pattern. Negative 0.180 matches the 0.18 here. And I want to plot initial pH and delta pH. So insert scatter plot. There it is. I want to double click on the axes. I'm going to go from 2.4 to 5.6 and leave the rest of it as is. And there we go. So those are our two figures, and they are an inversion of each other. Right? If we put them together like this, we see that they're kind of they're going inverted across the middle. We have matching points. And we also see, right, this is kind of get to the last question, right, what does this all mean? But remember that the pKa is 4. And at 4, delta pH is the smallest value. And so it's going to be the smallest change in pH is the most resistant to change. So buffers work best around the pH. But actually between about 3.5 and 4.5, there's really not much change. Those are pretty much kind of all in line, right? And so there's a nice range about pKa plus or minus 1 where we don't see a whole lot of change. Okay, I'm going to stop this one for now.